Political considerations are in effect that prevent the issuance of a passport for Frau Professor Meitner. It is considered undesirable that well-known Jews leave Germany to travel abroad where, with their names and their corresponding experience, they might even demonstrate their inner attitude against Germany. Surely the Kaiser Wilhelm Society can find a way for Frau Professor Meitner to remain in Germany even after she resigns. This represents the particular view of the Reichsführer of the SS and the chief of the German police, Heinrich Himmler. Heil Hitler.
Lisa now knows she must escape illegally and fast. There's no time to lose. A fellow scientist at the Kaiser Wilhelm Institute informs the police that Lisa is about to flee. In Copenhagen, Niels Bohr is alarmed. He contacts Lisa's friend Dirk Koster in Holland. Koster and another physicist begin an intense campaign to get her out of Germany and into Holland. Then on July 4th, 1938, Lisa learns that the National Socialist policy forbidding all scientists from leaving Germany will soon be strictly enforced. If she tries to cross the border, she could be arrested, or worse. At that moment, another offer arrives from the new Nobel Institute for Experimental Physics, devoted to nuclear research and headed by Mona Zygban, a Nobel laureate and one of Sweden's most influential physicists. In the meantime, Dirk Koster boards a train for Berlin. He travels through picture-book medieval German towns draped with swastikas. Police and soldiers are everywhere. Passports are checked and rechecked. On his way from Holland to Berlin, Koster talked to the Dutch border guards asking for their help. He hoped they would speak to their German counterparts and help Lisa cross the border.
The danger consisted of the SS's repeated passport control trains crossing the frontier. People trying to leave Germany were always being arrested on the train and being brought back.
On the morning of July 13th, Lisa arrives at the Berlin station. She boards the train. She in one door, Koster in another. He sits next to her. Lisa packs only 2 small suitcases with some summer clothes. All her life's work is left behind.
We were shaking with fear whether she would get through or not.
She gets through. Lisa escapes without incident. Koster sends a telegram to Hahn. Baby arrived. All is well. At the Institute, many rejoice that the Jewess is gone.
There's no question that it was devastating for her. It's no question that she fell into a terrible depression. And I say this just on the basis of her own letters. Let me read you a few quotes from her letters. At one point she says, she writes to Hahn, "One dare not look back, one cannot look forward." Black statement, and she repeats it again in another letter. "My future is cut off. Shall the past also be taken from me?"
After a few weeks, Lisa travels on to Stockholm and the Institute of Mona Zygban. She soon realizes that work at the Institute will be nearly impossible.
Meitner is very disappointed in Zygban's Institute. She thought she would be welcomed with open arms. After all, she's one of the world's most prominent nuclear physicists, and instead she was isolated. She was given a small room. It was a very lonely and unexpectedly poor reception in Sweden.
Suddenly, on his doorstep, one of the world's leading nuclear physicists arrives. How do you treat that person? You integrate that person into your research team. But what he does is simply keep her out.
For Hahn and Strassmann, however, Meitner remains a member of the Berlin team. Throughout the fall of 1938, Otto frequently writes to Lisa about their progress, often asking for advice and interpretation on their experiments with uranium.
One of the things they're looking at is a report by Irene Curie from Paris of a new substance that derives from the irradiation of uranium with neutrons.
The Curie substance is radioactive and present in amounts so small that it can only be detected by a Geiger counter. The new radioactivity behaves like barium, but Hahn and Strassmann do not think it is barium, since they expect only small changes in nuclear reactions. So they conclude that the new substance must be radium, which is chemically similar to barium, in the same group in the periodic table. November 9th, 1938. The night of broken glass. The Kristallnacht. An organized government pogrom against the Jews. 4 days later, Hahn travels to Copenhagen, where Lisa is visiting the Bohr Institute. It has been 4 months to the day since they last saw each other, and he is eager to discuss his latest findings with her.
Meitner came to meet him at his train. They went to his hotel, had breakfast, and talked for hours. And we also know from Hahn's diary that Hahn met Niels Bohr, he met Otto Robert Frisch, and other physicists in the Copenhagen Institute, and they all objected to Hahn's new radium findings.
Hahn soon returns to Berlin, but in Europe the political situation is getting worse. Hahn realizes that he cannot tell anyone that he has met with Meitner, not even Strassmann. But he does tell him that Lisa has urgently requested that they re-examine the radium findings. And so they begin a new experiment. To prove they really do have radium, they will separate it from all other elements. Their method is fractional crystallization, or fractionation.
They fully expect that they'll be able to separate the radium from the barium carrier.
But the experiments do not go as planned.
19 December 1938. Dear Lisa, last week I fractionated thorium-X. It went exactly as it should. Then on Saturday, Strassmann and I fractionated our radium isotopes with mesothorium-1 as indicator. The mesothorium became enriched. Our radium did not. It could still be an extremely strange coincidence, but we are coming steadily closer to the frightful conclusion. Our radium isotopes do not act like radium, but like barium.
And what they find, and this is the big discovery, they find they can't separate those radioactive isotopes from the barium carrier.
There is something about the radium isotopes that is so remarkable that for now we are telling only you. They can be separated from all elements except barium.
And if you can't separate it, there's only one conclusion. And they reached this conclusion shortly before Christmas, 1938. Their conclusion is that those isotopes are not radium at all, but are actually barium.
Uranium has produced barium, radioactive barium. This is what Hahn and Strassmann have found. But how can a uranium nucleus change into barium, which is so much smaller? Hahn needs a nuclear physicist to explain this mystery. He turns to Lisa Meitner.
Perhaps you can come up with some fantastic explanation. Before the Institute closes for Christmas, we do want to write something for publication, so please think about whether there is any possibility.
21 December 1938. Dear Otto, your radium results are very startling. A reaction with slow neutrons that supposedly leads to barium. At the moment, the assumption of such a thoroughgoing breakup of the uranium nucleus seems difficult to me. But in nuclear physics, we have experienced so many surprises that one cannot unconditionally say it is impossible.
Hahn was mystified as to how that could take place, how there could be barium among the reaction products.
Otto Hahn made a discovery in late 1938, but he didn't know the meaning of the discovery.
She is the physicist. It's up to her to explain the data from chemistry that doesn't make any sense.
Intuitively, Meitner was ready for the massive breakup of the uranium nucleus, even though the idea had no place yet in nuclear theory.
If there is anything you could propose that you could publish, then it would still, in a way, be work by the three of us.
It's Christmas. Lisa is spending the holidays with friends. She invites her nephew, Otto Robert Frisch, a physicist, to join them. After their arrival, Frisch finds his aunt studying Hahn's letter and obviously worried about it.
Hahn and Strassmann had found that those substances were not radium, but barium. We took a walk up and down in the snow, I on skis and she on foot, and gradually the idea took shape.
This was no chipping or cracking of the nucleus, but rather a process to be explained by Bohr's idea that the nucleus is like a liquid drop. Such a drop might elongate and split in two.
At this point, we both sat down on a tree trunk and started to calculate on scraps of paper, and we found that the uranium nucleus might indeed be a very wobbly, unstable drop, ready to divide itself at the slightest provocation, such as the impact of a neutron. But there was another problem. When the smaller two drops separated, they would be driven apart and would require a very large energy, about 200 million electron volts in all,